Well, hi everyone. Thank you for being here. My name is Aurora Ruiz, and I'm from the University of Twente in the Netherlands, and I'm going to be talking to you about the designing of video games for motor rehabilitation. So the first thing is to explain a bit what are video games. Most of you already know, I suppose, that these are systems developed for entertainment purposes. The idea is that we keep the individuals or the gamers motivated to use them. Um, there are different type of video games that we can find, and a nice definition are the serious video games that are the type of video game which principal purpose is not to entertain. They offer a new mechanism for teaching or training, combining video games and education. From these serious video games, we can find several different areas. And today we're going to focus on some specific type of serious video games that are the therapeutic video games. So in therapy, we can have all this training or the healthcare area involved. And the modality of these video games are the physical type of video games. When we talk about physical video games, we talk about exergames. And exergame systems are this combination with exercise and gaming. So every video game which involve any physical exertion of movements are called exergames. This involves strength, balance, flexibility, any type of activity that makes you not being sedentary. There are commercial extra games that we can find on the market. Maybe you already know something like the Wii Fit, the Just Dance from the Kinect, or any other video game that makes you wants to move. So these commercial extra games are made for entertainment or for fitness, for everyone to work out, but they don't address the requirements of a rehabilitation therapy, which is very important. So in extra games and rehabilitation, we need to uh, find exactly and develop what aims to promote this motor rehabilitation, how to improve this physical and mental state from the patients during this therapeutic process. And these video games become a very important part from occupational therapy. They increase motivation in rehabilitation practice. And of course, for best results in rehabilitation, video games are a very important part because when they are designed for therapy, patients want to use them. A very important part to keep in mind is that these video games needs to be designed specifically for the user, so for the patient. So we have these tailored exergames that the personalization or computer tailoring refers to how to adapt this persuasive technology to the individual. So this type of exergames rehabilitation warrants the balance. This type of tailored exergames can guarantee that the individual will be able to use the system because it's made specifically for the patient. We also need to keep in mind that according to the therapy, we need to focus on the type of patient. So define this population that we will talk a bit more in the next slides. But each population, children with autism, elderly, people with a stroke, or any other motor thing that we need to work, needs a different type of tailoring. Regarding the motor skills that I'm telling you about, we can find these two types of motor skills that are the fine motor skills regarding the hand movement and the gross motor skills regarding the body movement. So there are in research different type of related work regarding video games with motor activities. So for example, here we can see the Be Smart, that is a video game designed for children with Down syndrome, where they can work the eye-hand coordination. We can find the finger extension flexion, that are also to improve hand-eye coordination, but only for children with between 6 and 10 years. And also there are these video games for the lip motion sensor for children with autism, also to work these fine motor skills. Regarding the gross motor skills, we can find, among other projects, Clock Yourself, that is also involved the cognitive side and the physical side for stroke survivors. We can find systems for elderly, like the interactive wall, where they move around and are selecting different type of pictures that they had from their past. And also for children with autism, we can find the Bomb Bash. That is also a touchless game for they to move and interact. So far, what we see in this project is that the most important part is the user. So when we are going to design system for them, we need to focus first on the user. So we use a user-centered design. We can have these 4 stages that are the basic one. So first, understand the context of use. We need to see who is the user and where are they going to use the system. If we want for them to train at home or in a clinic, then we need to really understand where is the system going to be used and by who. Then specify all these user requirements. For example, if we want to make a video game for children with Down syndrome or children with autism, we need to make the difference that even though they are both children, they have different necessities. So with children with autism, we cannot have an overwhelming stimuli, like very loud noises or colors, sounds, all of that. With Down syndrome, we know that the cognitive side is different, so we need to work for them. So all these requirements is regarding the population. Then we start designing some solutions regarding the requirements, and we evaluate all this idea until we come up with the final design. When we work with motor rehabilitation, we need to specify one very important requirement when we go to the designing of the solution, that is, which device are we going to use to track the movement? We can find pressure mats when we walk or do some gross motor movement. We can have a mat to track that movement. We can have different camera-based sensors. Most of you know the Kinect. There's also the RealSense camera that can track the whole skeleton from a person, and then you can analyze how is the movement going. We also have devices to track the hand, like the lip motion, or maybe some attached sensors, like flexometers or any other sensor that can track the hand movement, or the cell phone. The cell phone is also being used in some Exergames to identify how are you moving or where are you moving the cell phone. So when we fix these requirements, we need to see if it's going to be hands-free, if we want something less intrusive, or if for the population it's not important to be intrusive or not, if it's comfortable, not comfortable, all of that. Then there is this big difference regarding a normal Xray game, a commercial Xray game, and a therapeutic exergame. With this type of simple exergames, we have one goal, the primary goal. We have one exercise and we have the gameplay. So in games like the Xbox Sports or the Wii Fit or any other commercial extra game, we are doing some movements in a virtual environment and we get some points. And so we have the gameplay, we know what we're doing, and that's pretty much it. And in a therapeutic extra game, we have this primary goal that, of course, we need something fun for them to be engaged. We have a nice gameplay for the gamer or the patient to be involved. But we also have a secondary goal that is a virtual therapy. If the patient do a wrong movement, we need to address it immediately. So we have to have this feedback so they can improve and do the therapy in a correct way. So the extra games are focused on primary goals and they really don't focus on the secondary goals. And the therapeutic extra games need to focus on this feedback. Is very, very important to keep that in mind because it's how the patient will improve, such as is done in a traditional therapy session. When we want to design a safe therapeutic extra game, we can follow this nice methodology by Pirovano that focuses on these 4 stages. So, for example, if we want to design something for a gross motor rehabilitation, first we need to define an exercise. So if we're going to flex our legs or do some walking or something like that, we need to define which exercise are we going to do. Then when we know what we want to train and improve, we are going to virtualize this movement. So we start with the virtualization. So we need to keep in mind, how are we going to virtualize the movement? How are we going to track the movement? So which type of sensor or device are we going to use? And having all that in mind, you can virtualize the movement. Then you need to have this movement in a game. So you start thinking in a game stories, all the conceptual part, how are you going to keep the player engaged, and how are you going to make sense that the movement is in a real game, not only do the movement and that's enough, but what are you getting by doing the movement? So having all these gamification part involved with the exercise that we define. And the last part, well, super, super important, is apply the secondary goals. So you have the game on track, then you need to put this mechanism or have a mechanism for immediate feedback and knowing that you are doing the correct movement and that you are not going to hurt yourself by doing something wrong for a long period of times. One example that I can show you right now is the last research project that I was involved, that is called Busy Hands. It's a video game focused for children with autism, where they needed to work their fine motor skills, so the hand movement. So the first thing that we did was to define what movement was important for them to work. So it was the pincer grasp, so doing this type of movement. And one virtual environment that we can work with was eating or having this simulation of eating breakfast. So the children had to do the pincer grasp in a correct way, go and get the spoon, do the hand movement, and make like he was eating. So it was the fine motor skills and the coordination. So we virtualize the movement in this sense, and we also tailor regarding each patient and how they needed to work. So one way to make this personalization is by a menu where the therapist could modify how was the precision. So if there was a children that needed more help or who needed to work more in these fine motor skills, we were not gonna push for a precise movement because we want some improvement, so step by step, so we can define the precision of the pincer grasp. Then how many repetitions what he going to have and which hand he was going to work with. So defining all these parameters, the therapist could see if they were working in a correct way or not. Then in this secondary goal, it was to see if the pincer grasp was in a correct way. And a way to do this was to get points. So every time the movement was done in a correct way, you get a point. If not, you don't get a point. And feedback that they had was in a visual way, how is the movement they need to achieve and what they need to grab. So if they need to grab the spoon, they can see the hand, the spoon, and they can go for it. So in this sense, we focus on the user, we focus on the requirements, we virtualize the movement, and then they can train these activities in a more fun way, but also with the supervision of a qualified therapist, of course. So with this, I would like to thank you very much for listening, and I'm open for questions and answers. Thank you so much.